Some people might probably know it from the Oktoberfest. It's the most famous event in Munich, and I'm currently moving to Hamburg. And I think it's really amazing to be working for a company that gives me the opportunity to move from city to city. But what's even more amazing is to be invited to different countries, to be speaking in front of people. So I want to really thank the entire crew of Rolling Scopes for inviting me here. I want to thank all the people that are here to listen to my talk. So why am I here? Because I am a really insane CSS nerd. I do a lot of insane experiments in CSS. And I'm going to be showing you. Obviously, my experiments are bleeding edge, and some of them don't work, and you might all be expecting this talk, entering the fourth dimension in CSS. I've been working on this talk for the last 3 months, and sadly, I couldn't get it to work. This is a 4D cube. It's a 4D implementation I made in CSS. And I was trying to get it to rotate in the fourth dimension. It's really complicated. The performance kind of failed, and I wasn't really happy with the quality. So I decided to change my topic, and it's still going to be amazing, I hope. So I'm going to be talking about CSS fractals. And this is more or less going to be a guide on generating fractals in HTML and CSS. So let's define a fractal. What is a fractal? I looked it up on Wikipedia, and this is what it told me. I had to shorten it a little, and there's some key words. It's a mathematical set, and it's the same at every scale, and it's a pattern that repeats itself. So let's play a little game. What is a fractal? Is a coin a fractal? No, not really. Is a stone a fractal? Stone isn't a fractal. Maybe if you look at the granular parts, it's a fractal. But then if we look at a snowflake, that is a fractal. And why is it a fractal? Because it just keeps on going and going. And trying to explain a fractal to people that have no mathematical background or just don't know what it is, I figured, let's ask the question, is a matryoshka a fractal? And yes, it in fact is a fractal. It's actually a really nice way to show what a fractal is, because we've all had this in our hands, and we've opened the matryoshka, and inside is another one. And then we could keep on going and going. And I like this picture because, like, the smallest part is this. Yeah, the smallest part you can almost not see. But you could imagine it's just going on and on. So now I have to see if this is working, because I have to quickly switch to the browser. Oh, there we go. So what I did is I actually made a matryoshka in CSS. So now if we hover this one, there's another one, and then we can do that again, and then we can do that again, and it just keeps on going and going. And you could actually imagine this matryoshka as a type of a component. I just stacked them in each other, and so yeah, I did that. Oh, yeah. I figured let's just call it Matryo CSSka. So, is it a fractal? Yes, it's sort of a fractal, and it's not what I'm going to show you, because if I were, now this talk would be over, and that would be quite boring, right? So, the next thing, something really amazing. It's probably the fractal I love the most. As you probably all know it, it's the Mandelbrot set. And it has been found and named after Benoit Mandelbrot. And the cool thing about this thing is you can just zoom into some part, and while you do, oh, sorry, this is kind of not responding correctly. While you do that, you get, you can just zoom in and it will just scale. And up here you can see the next Mandelbrot set. It's like the Mandelbrot lake, right? And so if we were to zoom in there, or we were to zoom into this point, we could just keep on going and going. And if we add some colors to this, it's going to look like this. And it just looks amazing. Like, having this animated is, I mean, just thinking about all we're doing is zooming, and all these shapes seem to be dancing with each other. They seem to be moving, but it's not actually moving. I do not have any mathematical background. I do not have any programming background. So trying to implement this was kind of, I wanted to do it. I didn't want to do it in JavaScript because it has been done so many times, and I worked really hard on doing this. But in the end, it was really easy, because what I did is I implemented it in SCSS. And I've never seen somebody do that before. I also posted this on Rosetta Code. And this is like the basic code that, the basic loop that generates the logic behind the fractal. I really like SCSS because SCSS, it stays in the syntax. This is definitely CSS syntax. But honestly, this doesn't look anything like SCSS. And the thing is, I have to do really, really evil stuff. I have to set a flag that I can use to check, so it's not running that often. And depending on how many iterations I'm running the, yes, question? Oh, this is a slide. I have everything later, so I can make it really big. I just don't want to switch right now, but I'm going to switch in about a minute. So depending on how many iterations I'm calculating this Mandelbrot set can be more exact or less exact. This is actually a picture I found on the internet, and it displays it really good because you can see, okay, if I'm doing 5 iterations, this doesn't, it has the shape, but it's not really, and it's getting better and better. So yeah, the Mandelbrot set in CSS. What I did is I rendered as one element, so the element is called Mandelbrot set. And then I'm just generating a lot of box shadows to actually display. This is just a small snippet of the code, and the entire magic is here. And you can see, okay, this is a big box shadow. In the end, it looks like this. It has 160,000 points. That's 400 times 400 pixels. I ran it with 70 iterations, and it took 3.5 hours to compile. So, is it a fractal? Yes, definitely. But it's way too complex for CSS. And it's not what I'm going to show you. What I'm going to show you, just because I was asked now, is the code for this. So is this big enough? Yeah, perfect. So what I did, I basically set some settings, as you would expect in any function, to have the ability to put some settings, and then I have this part, don't edit beyond this part, and this is the entire logic. First, I implemented some complex math functions, because I am using those, and then I'm starting the entire, I don't want to go into this in detail because it's really complicated to explain. But in the end, what I get is the Mandelbrot set with the margin and then with this really long box shadow. But like I said, this is not what I'm going to show you because it's not, well, it takes 3.5 hours to compile, so if I were to show it to you, the entire day would be gone. So I thought about what else can I show? How can I implement fractals in CSS? So I picked something simple. This might not look simple, but it's actually based on some mathematical functions, and it's actually based on the Pythagorean theorem. And this just says the square of A and the square of B makes the square of C. And based on this function, I was able to implement the Pythagoras tree, and the logic is done in 7 lines of CSS. Don't believe me, this is the CSS. All I have is this div, and then I have a height and the width, which is the square root of 100. Oh no, it's 100 divided by the square root. And then I'm just setting some basic properties. And I'm going to do some live coding later, so don't worry about the font size. I'm going to show this in detail. The magic that actually makes the tree is this line. And since it's a WebKit prefix and this only works in WebKit, it only works in Google Chrome. But I don't worry about that because it's an experiment. And I'm just testing stuff. So, is it a fractal? Yes, it is. And it is simple enough. So, let's see what we can make with it. This is what it actually looks like in the end. And now, if we were to change the angle of this part, we could generate different shapes. And so, is it still a Pythagoras tree? No, kind of not. Then what is it? A Pythagoras, what is it? It's kind of a CSS fractal, because if we start, and can you see this? Because if we can't, we have to turn on the lights now. Can everybody see this? Yes? Okay, thanks. So if we play with the colors, we get these really awesome looking shapes. And if we do even more magic with the colors, like changing, depending on the depth we want to change the color, we get something like this. And then if we start animating this, actually don't want to switch to the next slide yet. We can animate this, and because we can animate this, I figured let's do something funky. Let's maybe analyze audio and then generate fractals. So we actually have audio visualization that's based on CSS fractals. And okay, yeah, okay. So this is also just one stage of the fractal, and then if we animate it, it moves around, and it gives these really amazing shapes. And I actually figured this out by mistake, because I was playing around and doing all kinds of stuff, and then suddenly this really huge thing popped up. Like, wow, this is going to be a talk. So I'm guessing that some of you are confused. So let me just show you what it looks like in real life. There it is. Oh, this is a little complicated because I have to work on this screen. Okay, so let's just let me just explain what's really going on here. What I actually have is what I actually have is this structure. I have a div, and these class names are really not important for this kind of experiment, but they're going to be important for the audio visualization. So just don't worry about the class names. But in the end, it's just a div with another div inside, and just another div inside, and another div inside, and that's actually what's happening. So if we only have one div, this is what it's going to look like. So now if we take more divs, say we want to nest 4 divs in each other. I'm using Jade here because it's really easy to modify this for this talk. It should be. OK, live loading is not working, but it's not a problem. It's just going to extend. So I'm taking a div, then resizing the one that's nested, pushing it on top and on the left, and doing that over and over again. And that is basically what's happening here. So I defined a size. This is 100 divided by the square root of 2, which is approximately 71%. And then I'm saying the transform origin is going to be 0 and 100. So it's going to be 0 and 100, so 0 and 100. This is the rotating point. So this is the angle that I'm going to open. And then I actually don't need the transition. So the next thing I can do is put in the rotation. So every element that is nested, I'm only taking the nested divs, now gets a rotation. So now this happened. I just opened these, and this is now tilting inwards. So let's go a step further and take this to 12 divs. After 12 divs, it looks like this. And this looks nothing like the tree. This has nothing to do with it. It's just one branch. And now here's the magic part. With just one more line of CSS, I can now generate the entire tree. Because in WebKit, we can do the following. We can just say WebKit box reflect and reflect everything to the right. So what's actually happening, I'm going to the deepest nested div, reflecting that, and since every div is reflecting everything, including their children, it's like a recursion from the inner to the outer part. So what I've now created, oh, I didn't save, I guess. Is this. And it's a little off. I think that's because the screen is too big. Yeah, this is also dynamic because I'm working with the viewport width, so I can actually zoom in, kind of. Yeah, so it's really simple. This is, with the color, it's 9 lines of CSS, and that's it. I'm doing some funky stuff to the body and to the HTML. It's basically just a flexbox concept. So the body is actually sitting here and really small, so I don't have to put too much logic in this. So the next step is going to be the animation part. So what I'm going to do is going to use a keyframe animation, and I'm just going to rotate the element. And I'm just going to rotate oh, actually, let's just keep this away for a second. I'm just going to rotate that part, and now this is happening. So yeah, okay, this tree is opening, and then it's closing again, and now we can see how I got all those shapes that we saw before. But it's not really interesting, because it's just doing the same thing over and over again. So let's just add some randomness. For example, let's say we want to change the background color. And now we have something like this. And it gets more interesting. And now I'm kind of bugged out by the white square that's here. Because it's a deal breaker. It just doesn't look good. So let's also remove that. And now we have something like this. And now I kind of felt it's kind of edgy, so I thought about maybe adding a border radius to that. So now we have a bunch of circles. And to make it even more granular, let's not do that, but let's instead make it entirely round. So we now have 2 parts, so now we doubled it again. So we get these really, really crazy shapes. And since it's still moving at the same speed, let's add some randomness to the animation duration and delay. So now we have something like this. And it's moving and moving, and then it's spreading apart, and it has nothing to do with the shape we saw before. Now, each dot seems to be not connected to the other dots, but they still rely on each other. And yeah, so this is, even though I've seen this 1,000 times now, I'm still impressed by what we can actually do with CSS. And this is just a really simple implementation. But what I actually also did, and this is the first one of this kind that I made, is this thing. And I called it CSS on asset, because this is like imagining that if you see all those movies, this is what asset is described as. It's just amazing. And this is still pure CSS. There's no JavaScript involved. There's nothing involved. Still, it only works on WebKit because of the box reflect. And I've never had a use case for that until now. So yeah, I talked about, oh, there's another thing that's actually pretty nice. It's adding some colors to the tree. We could have something like this. This is the same code, but I'm actually adding a box shadow on a few elements, and the deeper I get, then I stop adding the box shadow and just giving it the green. So this is actually, if you Google for Pythagoras tree, you're going to find this picture. So the next thing I then did was, actually I had this idea when I was at the JS Conf last year, and a friend of mine, Tim Petruski, talked about listening to web audio, and then he had some hardware and did with some LEDs and did some, well, he basically tried to do some light mapping with JavaScript. And I listened to that talk, and then I started trolling him, and I started talking to him, and I was like, amazing, let's do something together, because I made these fractals, and I want to do these, and I want to animate those with web audio. And so I talked to him and got a lot of ideas, and then I implemented that. So since this is going to be on YouTube and not every country allows playing songs, I'm only going to play like 10 seconds, so I have a lot of songs here, so you can just see how the different shapes are created. And Yeah, basically here, right here, somewhere the fractal thing, you can't see it because it's not visible, it doesn't have any color, because the color and the rotation is depending on the analyzation of the audio. So I'm basically analyzing, then getting the average frequency, and then prior to that, I'm rotating and coloring the fractal. I'm gonna start really slowly because I don't know how loud the speakers are. But yeah. Yeah, so this is just some song and it's generating this fractal. And maybe I think the third song is there's a little more action in it. And you can see, this is, I don't know, like I said, I'm still amazed by this, because this is CSS, and I've been thinking about doing visuals, and most of the people do that on Canvas. So I figured, why not do it differently? And this is the result. And I'm also going to intro this song, because one of the guys from Rolling Scopes told me that this would probably work pretty good, and it actually does. Maybe you know the song, I don't know it, but it actually shows how this is going to build up. Those are the parts that I think are amazing. Just seeing how it really interacts with the music. Yeah. Thanks. Yeah, so basically that's it. And I always like those troll pictures because it's not all about questions. You can, if you want to troll me, this is also like the point to do it. Yes, please.
I have a couple of questions. First, you told that compiling one fractal take about 3.5 hours.
Mm-hmm.
Have you compiled it only once, or you have compiled it, found mistakes, fixed, and then had to recompile it?
What I actually did, that's also, I have this experiment on CodePen, and it won't compile more than 5 iterations. And I basically check it with 5 iterations. And then I ran it, and then when I did 7 or 8 iterations, it took about 20 minutes. So I actually waited that long, and then I checked if it was working.
Mm-hmm.
And once I was really confident that it would work, I actually just let it run overnight. And the way I know that it took 3.5 hours is because I was using TimeGrunt, and it just showed me how long the task took. And it was 3 hours and 22 minutes. So that's how I figured that out.
Okay, second troll question. Why your nickname is Chrome is Pixel S?
Oh, I have been asked that before. It's actually a funny story because when I started developing, I founded this company, and it was called Bube, Dame, Pixel, Ass. And it's basically German for Jack, Queen, Pixel, and Ace, like Jack, Queen, King, and Ace. And then I figured, okay, I was telling that URL to people, and they were like, what? So I figured, okay, let's just shorten it and call it Pixel Ass, and because I can be an asshole about stuff. Like, I'm really picky, and the stuff I do is pixel perfect, so it actually fits. Yeah, I'm an asshole about pixels.
I see. And the third question, can we see this somewhere in the web? Can we download it and, well, meditate on it?
Again?
I mean, can we download that fractal somewhere or see them somewhere? Are they published, I mean, on GitHub, or are they on
everything that I showed you today is on CodePen.
On where?
CodePen.
Ah, I see. Where are the links, or how can we?
I will definitely. I mean, all the slides are going to be online. I'm gonna upload them. Oops. I'm gonna upload them later. But basically, if you go to codepen.io/pixels, you don't get a web page. Why not? Oh, it's not working?
So they are there, yeah? Or will be there?
Yeah, but on codepen/pixels, I'm definitely going to tweet that. Yeah, on that URL, you're going to see all the experiments. I have a lot of collections, so on the site, you can just look through the collections. I have a lot of 3D elements and then a lot of fractals too. So just look through that. And also what you probably want to be doing then is just follow me on Twitter. The name is up here. It's @Gregor Adams. And I'll be posting that like anytime that I'm doing new stuff, I'll be posting that.
Okay, thank you.
Okay. It's just any more questions?
Any at all?
No?
No, that's it.
Okay. There's some things because I figure maybe people are not going to ask questions, and there are some questions that a lot of people ask me, and I just want to answer those because maybe it's interesting to you. The first thing is why use CSS. A lot of people ask me, why am I doing this in CSS? The people say, okay, you're super creative, you seem to be super smart. People like you should be doing super crazy stuff in Canvas or in WebGL. But the main reason is that what I really like is the DOM, like having the ability to inspect elements and then working in the web inspector, and with the possibilities that Google Chrome is giving us to really have the ability to live code inside the browser is really amazing. Then what other people ask me is, how does it help you at work? Because people are like, this is totally crazy stuff. You cannot profit from this at work. And I can, in fact, profit from it because I'm an architect. I have to work, I have to decide on things. I have to test things. I have to look at, is it still performing correctly? How long is it taking to compile code? How can I make my code smaller, nicer, more maintainable? And with all these tests, I'm just doing stress testing. And then the next thing is, what do I think about Canvas and SVG? I have started doing Canvas stuff because people are trying to push me to do Canvas because they just want to see what I can create with Canvas. And I think Canvas is nice, and when it comes to performance, I would always switch to Canvas. With SVG, it's a whole different story. There are still some parts missing. That's why I'm not doing SVG. Like, you can't animate the path of an SVG, but you can do that with the clip path and CSS. So in those cases, I'm actually using CSS. But as soon as that gets implemented, I will be switching to SVG immediately. And yeah, that's basically it. And what is it? Da Pabachinya? Oh, thanks.